so let's talk about formal charge. So what is formal charge? So during bonding, sometimes atoms may wind up with more or less electrons in order to fill up their octets. So they might have more or less electrons than they kind of normally would in their everyday neutral setting. So this results in them having a formal charge on their atom while they're in the bond. Okay? So it's not the same as a cation or anion, because cations and anions are when they're just an element chilling by itself. Okay? This is when the element is bonded. So that's why it's a little different. So how do we calculate the formal charge? It's actually a formula. So the formal charge is equal to the number of valence electrons for that specific atom minus the non-bonding, so any electrons just on the atom, just chilling, and then half of the bonding electrons. Another way you can do this is instead of half the bonding, you can say minus the number of bonds. Either one. Because if you do half the bonding electrons, it's the same thing as just counting bonds. Okay? Either way. So we're going to practice writing the formal charge for this guy. So I want you to draw this on your notes. We're going to practice. So if I asked you to calculate the formal charge of all of the atoms in this Lewis structure, the way you would do this is you would say, okay, I'm going to do it for the oxygen, but I'm going to specify because I have two oxygens. So it doesn't matter how you drew it. If you put the double bond here, what you need to do is you need to tell me which one you're talking about. So I'm saying for the left oxygen, this is going to be my formal charge. There's only one sulfur, so I could just say sulfur, and then I could say right oxygen. So this is me calculating the formal charge. So let's look. Left oxygen. First, it's the number of valence electrons. So it's an oxygen. So how many valence electrons does oxygen have? So I go on the periodic table and I look, 6. Okay? So he has 6 valence electrons minus the number of non-bonding. So as my Lewis structure is drawn, he has 1, 2, 3, 4 electrons just on it. Minus the number of bonds, or half of the bonding. So if we say half the bonding, we have 1, 2, 3, 4 bonding electrons. Half of that is 2. If we say the number of bonds, there's 1, 2 bonds. So 6 minus 4 minus 2 gives me 0. So he has a 0 formal charge. Let's do the sulfur. How many valence electrons? Sulfur has 6 valence electrons. Okay. How many non-bonding? He's got 2 electrons just chilling. How many bonds? 1, 2, 3. So he has a +1 formal charge. All right, let's do the right oxygen. Oxygen, we already said, had 6 valence, so it's the same. How many non-bonding? 1, 2, 3, 4, 5, 6. How many bonds? 1. So he has a -1 formal charge. Okay? Now, this is SO2. This is how I would write that. It's just SO2 is the formula. So as the formula is written, it's neutral. So if my molecule is neutral, the sum of all my formal charges should also be neutral. So if I add them up, 0 plus 1 minus 1, it's also 0. So if it is a neutral molecule, the sum of my formal charges is also going to be 0. If it is an ion, say there's a charge here, then these formal charges will equal whatever the ion charge is. So if in an ion, the total equals the ion charge. All right, so what we're going to do now is we're going to say that after I go through and I do my steps. So step 1 is skeletal structure. Who goes in the center? Least electronegative. Step 2, add up my electrons. Step 3, make single bonds with everything. Step 4, make the outside electrons happy. Then I have to make the central atom happy. That's where step 5 and 6 kind of come to play. 5 says if I have extra electrons, put it on the central guy. Step 6 says if I don't have electrons, or if I put some of them but I still need more, I make double bonds. So 5, 6 kind of go together to make that central atom happy. So that's where we were. But sometimes when we're trying to make double bonds, we don't know which choice to make or whatever, okay? That's where we get to step 7. So we use step 7, our formal charge, in 2 situations. If I have 2 choices when I'm moving electrons, I do it. Or if my central atom can expand. We haven't talked about expanded octets yet, but if it is in row 3, so row 3 or below can do expanded. So how do I know if I do expanded? Formal charge. Okay, so formal charge, if you have more than 1 choice when making double bonds, when we're moving electrons, or deciding if an atom does an expanded octet. All right, so that's where we're at. So what we're gonna do now is we're gonna go back to all the examples we've already done. So you're gonna flip back in your notes, or you could write them over on these pieces of slides if you want, and we're gonna go back. So we're gonna start with HNO2, and we're gonna go back to each one of them and say, do we do step 7? We don't always do step 7, but we have to go through it and see if we do or we don't. Okay, so that's where we're gonna be at now.